Right, we're going to look at section 5.2 today, and it is titled Bisectors in Triangles. So when you went through section 5.1, we talked about what a perpendicular bisector was, and a perpendicular bisector cuts each side or a segment in half. Okay, we're going to talk about it in triangles today. So each side of the triangle is going to be cut in half by a perpendicular bisector. Or we're also going to look at angle bisectors. And so when we have an angle bisector, each angle of the triangle is going to be cut in half. And so we're going to look at the difference between those. And typically in a normal year, we would actually get out the compasses and the straight edges, and we would actually do the bisecting ourselves. But we're not going to do that this year because we can't share the equipment. However, if you read through your notes, it says the perpendicular bisector. So just want to emphasize a few things. The perpendicular bisectors of all three sides of a triangle will meet at a single point. We call that a point of concurrency. So we're talking about perpendicular bisectors. You might want to highlight that in your note packet. So we're going to bisect each side of the triangle. And if we do that and we extend those sides, they're going to meet, all three of them, the three lines, the three perpendicular bisectors, are going to meet at a single point. And we call that a point of concurrency. And we call that the circumcenter. So I'm going to give you some vocabulary today that you're going to need to remember. And number one is that a circumcenter is connected to a perpendicular bisector. Okay, so you want to highlight those two in your note packet. And what's neat about the circumcenter, what's unique about it, is that the circumcenter is equidistant means equal distance. So the circumcenter is equal distance from the three vertices of the triangle, which makes it the center of a circumscribed circle. So what that means is if I were to construct perpendicular bisectors, which I'll do that in blue. So this line right here is a perpendicular bisector for this side of the triangle. Okay, if I were to construct another perpendicular bisector for this side here, okay, and then if I were to construct a perpendicular bisector for the final side of the triangle, they all meet at one point. All those lines are going to cross at a single point, and we call that a point of concurrency, specifically the circumcenter. It's the circumcenter of the triangle. And if we took a compass and we put our compass point on that point of concurrency and we stretched the compass out and drew a circle, you would see that that circle would touch all three vertices of the triangle. So that really is the center of that triangle. It's equal distance to each corner of the triangle. Now, it said even though it's called the center of the triangle, the circumcenter actually can fall in different places in regard to that triangle. So if we have an obtuse triangle like this, and recall that to be an obtuse triangle means that you have one angle here that's greater than 90 degrees. So if the triangle happens to be obtuse, when you go ahead and you draw in those perpendicular bisectors, these are going to be your perpendicular bisectors of the three sides. Okay, that circumcenter is actually occurring outside of the triangle itself. So even though we call it the center of the circle or the triangle, doesn't always have to be inside or the interior of the triangle. But what we're saying is that if I put my compass point on that point and stretch and draw a circle around that, then it's going to be all three vertices of that triangle are going to touch the outside of the circle. So that point, that circumcenter, is equal distance from each corner of the triangle. And sometimes that point is outside of the circle. And then if it's a right triangle, so we have a right angle up here, if I were to do the same thing and construct the perpendicular bisectors, that circumcenter would actually fall right on the hypotenuse. And again, I can circumscribe a circle by putting my compass point on that point, stretching the compass out to a vertex, and if I draw that circle all the way around, you're going to find that each vertex of the triangle is going to be touching that circle. Okay, so if you're ever out driving around, especially in rural counties, and you see maybe a water tower built or you might see a fire station where, where are we deciding how to build? Where do we build these places, especially in rural areas where there's townships? They might construct a circumcenter, because if I have towns located in an area, and if there's a town, let's say at each vertex of that triangle, then I'm going to build a water tower that services all of them. I might want to find the circumcenter of that area in order to build that so that it has equal access to all three towns. Okay, so you can see this used in a civil engineering type of occupation. Okay, so a circumcenter is associated with a perpendicular bisector. The sides of the triangle are being bisected, they're being cut in half at a perpendicular or a 90-degree angle where the intersection of the side takes place. Okay, that's a circumcenter. The other vocabulary that you're going to get in this unit is called the incenter. Okay, it says the bisectors of all three angles. So now I'm going to bisect the angle of the circle. They're going to meet at a point of concurrency. So if I were to bisect angle A here, I would get this line right here. To bisect means to cut the angle in half. If I bisect angle B right here, it means I'm going to cut this angle in half. And if I bisect angle C here, it means I'm going to cut the angle in half. They're all going to meet at a point of concurrency as well. Now we call this point the incenter. Okay, here's the word incenter. And again, you're going to want to highlight that word in your packet. An incenter goes with an angle bisector. And that incenter is equidistant from the three sides along the perpendicular bisectors, which makes it the center of an inscribed circle. The circumscribed circle was outside of the triangle, okay, and it touched the vertices of the triangle. When we inscribe a circle, we're going to put our compass point on that incenter, and we're going to draw a circle inside of the triangle. That's why it's inscribed. And each side of the triangle is going to touch the outside of that circle. So what that means is the incenter is an equal distance from each side of the triangle. Not the vertice this time, that's the circumcenter, but it's equal distance to the side of the triangle. Okay, it says the incenter is always on the inside of the triangle. So an incenter has to be inside the triangle. Now, how do we use this information? Well, you're going to get some puzzles like this, and you're going to have to find different lengths or different values. So it says point T is the circumcenter of the triangle. Okay, so if I'm dealing with a circumcenter, here's point T. If I'm dealing with a circumcenter, that means that the circumcenter is equal distance to the three corners or the three vertices of the triangle. So this distance is the same as this distance. A to T is the same as B to T is the same as C to T. Well, I've been given the distance from C to T, that's 6. So that means the distance from B to T would also have to be 6. And the distance from A to T would also have to be 6 because they're all equidistant or equal distance. To find RC, okay, RC is this segment right here. Well, we know that a circumcenter is, the reason we get a circumcenter is because we had perpendicular bisectors. Perpendicular bisectors cut the side in half. So if this half of the side is 5, then RC has to be 5 units also. And then to find QC, QC is up here. Again, this side of the triangle has been cut in half, so if I have 4, from B to Q is 4, that means from Q to C is also going to be 4 units. So you can figure out those those distances by using what we know about a circumcenter. Okay, at the bottom of the page it says point P is the incenter. So now I'm working with an incenter, that means the angles. Here's point P. If that's the incenter, then the angles have been bisected in the corners. And we know that the incenter is equal distance to the outsides of the triangle. So from P to J is the same distance as P to K, is the same distance as P to L. Those are all going to be congruent. Okay, so he says which 3 points is P equidistant from? Okay, that would be its point J, point K, and point L. I skipped that question up here. I'm going to go back here in a minute and do that. And it says, so find the lengths. The distance from P to L. Well, we know the distance from P to J is 5, so that means the distance from P to L has to be 5. And the distance from P to K would have to be 5. And the distance from A to L. Okay, we're looking at this distance right here. Now, this is something that we've got to go back to what we did in chapter 4. Okay, let me show this. Let me kind of break this up. We've got two different triangles here. Okay, I've got a triangle right here, and I know it's a right triangle. Okay, which would make this the hypotenuse, correct? Okay, that would make that the hypotenuse of the triangle. I also have a triangle up here. Okay, and the right angle is up here, which makes that the hypotenuse of the triangle. So these two triangles down here, okay, we've got the one triangle here, and we have a second triangle up here. Those are both right triangles. Here's the right angle on the blue triangle. Here's the right angle on the red triangle. They share a hypotenuse. Okay, so this side has to be congruent because they're sharing that side. It's both of their hypotenuses. So it's congruent because it's reflexive. And then we also know that this piece right here is going to be congruent as well. That's the incenter. Remember, the distance from the incenter to J is the same as the distance from the incenter to L. So we have two sides of that right triangle that are congruent, and it happens to be the hypotenuse and the leg. So because of HL, those two triangles are always going to be congruent to each other, which means that this side that's labeled 12 is going to be congruent to this side that's labeled AL. So that distance is going to be 12. So we can use those congruent triangles that we learned from topic 4 to apply different values here and figure out what we need. Okay? And let me go just back up here. It says, which 3 points is T equidistance from? T was the circumcenter, which makes it equidistance from the corners of that triangle. So we would say A, B, and C. Okay, you got to know the difference between circumcenter, it's equidistance from the corners of the triangle. The incenter is equidistance from the sides of the triangle. Okay, go ahead and complete hopefully all of that in your packet you should have written down, and now you can give the worksheet a try.